The third example is slightly different. Is find the first 5 terms of the recursively defined infinite sequences. Here we are given the initial term A1 is 3, that's the first term. And then the following term depends on the previous term. You see right here, k can choose different values. If k choose 1, then 1 plus 1, you have 2. So A2, it depends on A1. Okay, because if k is 1, then here will be 2 times A1 minus 4. Okay, and here is k plus 1, k is 1 is 1 plus 1. So basically, this one is defined A1, A3, it's given. A2, here is 2, is because k is 1. And 1 plus 1, you have A2, and then 2 times A1 minus 4. A1 we know is 3, so then 2 times 3 minus 4 is 2. So in this way, you figured out A2 is 3. A2 is 2. Then A3 can be calculated by A2. Okay, so you see right here, A3 then equals 2 times A2 minus 4. Because if here is 2, then 2 plus 1 will be 3. So the third term depends on the second term. Okay, so you have 2 times A2 minus 4. That equals 2 times 2 minus 4, and then there's 0. Okay, so the third term is 0. You can figure out like A4 the same way. So A4 equals 2 times A3. Okay, because if here is 3, here will be 4. It's always, you see, 1 more than that. Okay, so then A4 can be found based on A3. Okay, so 2 times A3 minus 4, and A3 we know is 0. In this case, so you plug in 0 here, 2 times 0 minus 4 is negative 4. And then A5 depends on A4. Okay, if here is 4, here is 1 more than 4, so A5. A5 equals 2 times A4 minus 4. Okay, and then equals 2 times negative 4 minus 4. This negative 4 you plug in here. Here is A4, here is negative 4. So then you will have a 2 times negative 4 minus 4. The previous one, 2 times a negative number is negative 8. Okay, and then minus 4, then you have a negative 12. You can do this, recursively. So this sequence is different from the previous 2 examples. Okay, so this one is called recursively defined. And those are the sequences, 3 examples right here. All right, let's see more examples. In this example, we want to find the sum. The sum is that k ranges from 1 to 5. Okay, k ranges from 1 to 5. That means we want to find out the sum of the first 5 terms. If k is 1, then that's the first term. So 7 times 1 minus 8. Okay, and that's negative 1. The second one, 10 is what? Is 7, 1k is 2, so 7 times 2 minus 8, that's 6. Okay? The third term is what? The third term then is 7 times 3 minus 8. So 7 times 3 is 21. Yeah, 21 minus 8. is 13. Okay? Yeah. Then you can do is the fourth term. The fourth term is 7 times 4 minus 8. And then here 7 times 4 is 28 minus 8. You have a 20. Okay? The fifth term is 7 times 5 minus 8. And 7 times 5 is 35 minus 8. We have 27. Okay, we have 27. And then you add all those 5 terms together, is that you add all those 5 numbers together. Okay, which gives us 65. Okay, you see 13, 27 is 40, and plus 20 is 60, and then 66 minus 1, 65. And this one is similar. This one is that we want to choose the sum of this sequence. K ranges from 1 to 3. Sigma means the sum. Yeah, sigma means the sum. So write down here, K choose 1. So you have a 1 squared minus 9. That's the first term. And we know 1 squared is 1 minus 8 is negative 8. The second one is when K is 2. K is 2, then you will have a 2 squared minus 9. 2 squared is 4 minus 9 is negative 5. The third one is 9 squared 3 squared minus 9. 1K is 3. And then 3 squared minus 9 is 0. You add all those 3 together, is the same thing you add negative 5, negative 8, negative 5, and 0 together, which is negative 13. Okay? Now, look at the third one. The third one looks complicated. It ranges from K ranges from 286 to 618. And here is a constant, 1/3. There is no K involved. You see right down here, 1/3. No K involved. And here you have a K involved, so each term is different. And since there is no K involved here, so basically every term is 1/3. Every term is 1/3. Then how many 1/3 is actually involved? Let's look at that. The first one is 286. The second one is 287, 1/3. And then the third one is 288, 1/3. Okay? Yeah, 288, 1/3. Until 618, 1/3. So how many are actually over there? Look. 286, 287, then you have a 2 tenths. 286 to 288, and then you have a 3rd tenth. But 288 minus 286 is 2. So for 3 1/3, then you will have a difference is actually 2. For 1/3, 1/3 twice, 287, 286, the difference is just 1. So what do we get from here is that then you have a 618, the first one, minus 286. What do we get? We then get here is 8 minus 6 is 2, and then 1 minus 8 is 3. And we borrowed one already, so 5 minus 2 is 3. How many tenths? It's actually 333 tenths instead of 332 tenths. Okay, it's always the difference between two numbers. Add 1. Again, 1/3, 1/3 twice. The difference between 287 and 286 is 1. and you have 2 1/3. Okay, 288 and 286, the difference is 2, then you have a 3 1/3. Okay, so that's why we have a 33 1/3. Yeah, basically it's 1/3 repeats 333 times, and then you add together, it's the same thing. You use 333 times 1/3. You add 1/3 333 times is actually 333 times 1/3, which gives us 111. Okay. So basically in this lecture we talked about the sequences, how to use the general term to find out each specific term, and how is the recursive sequences is defined, and how to find out the sums. Okay, I'll see you next time.